weekend's over. Let's get settled down. Get out your notebooks. If you have not yet read Chapter 12, I suggest you start soon. It's a good introduction to Linnaeus and his theories. That is what we are going to be covering today and tomorrow, mainly for the week. Remember, we were discussing Mr. Ellis. Nice of you to join us. Please find your seat.
Yes.
For the weekend, we were discussing Linnaean taxonomy with respect to biogenetics. This is the classification system in which all organisms are, well, classified. Now, as I was saying, Linnaeus grouped organisms into 5 categories called kingdoms. These kingdoms have changed over the years, but the basic formula still remains the same. We go ahead and put these up on the board. We have, starting with Monera, Protista, Fungi, Plantae, and the one you are all most intimately familiar with, that animalians lack a nucleus, and several other prominent organelles common to the eukaryotic cell, such as the Golgi apparatus or the endoplasmic reticulum. Cnidarians came onto the evolutionary scene along with the echinoderms. Now that's where it all gets interesting as we see bilateral symmetry. Bilateral symmetry brings with it a whole slew of surprises, not least of which is the brain. Notochores, as well as separate orifices for ingesting food and expelling waste, accompanies bilateral symmetry as well. Arthropods, reptilia, aves, mammalia, etc., etc. And what we're really interested in this unit is how it all fits together. We learned the background already. Now it's time to the big picture. How do you focus together? How do you simultaneously
What?
The term, Mr. Ellis, what is the term that I am looking for?
Oh. Ecology?
It would appear as if you weren't listening to a word that I've been saying. But apparently that is not the case. Yes, ecology is the correct answer. Very good, Mr. Ellis. It is also referred to as behavioral ecology. Now, if an organism has a trait which provides them with a selective advantage in the new environment,